Hi, welcome to Kelsey Ed, and today we're going to be taking a look at input devices, the common input devices that will be covered in the IGCSE syllabus, and that includes where they're used, what they do, and for some specific input devices, we'll also look at the principles of operation, which is how it works technically. And then we'll look at some examination questions that you would face in the IGCSE so that you are fully exam ready for this section of the syllabus. So here are some of the most common input devices that you're going to find on this syllabus. First of all, we want to know what exactly is an input device and what's a definition if we get asked to define an input device. So basically, an input device is any device that is going to input data into the computer. And it's really important that we use the term data and that we understand that that is entered into the system. So here are listed the other input devices that we're going to look at. We'll cover all of those today except for touchscreen and sensor because those ones need their own individual video because they have a lot of more information about the principles of operation. But all these other ones we're going to run through today. So try and see how many of them you recognize just from the images right here or the names being listed. So here's some common input devices that you're going to need to know. And this is basically going to be more identifying where they would be used in different situations rather than exactly how they work, which is the principles of operation. So our first one is microphone and webcam, which I put together because we often find these together in video conferencing. We see this guy over here, he's got his headset with his microphone attached, he's got a webcam, and he's speaking with VoIP, which is Voice over Internet Protocol for video conferencing. So we should identify this as the most common use of microphones and webcams. After that, we have the interactive whiteboard. You're probably really familiar with these from your own classroom, and you may have even used one yourself. And it allows the user with their finger or with a specially made pen to be able to input to the computer the key presses, and even it has software for converting the handwritten text into a digital text. The important thing to remember here is that it's an input device, not an output device. The display that's on the board is actually displayed by a projector. It's not displayed by the board itself. The board is a series of sensors that are calibrated to be able to recognize the coordinates of your position. So in examination, you're going to recognize the description of this board as mentioning the fact that the image is displayed from a projector onto the board. It will also characterize this as being very large and possibly being mounted on a wall. Next is the digital camera, which uses lens and mirrors in order to reflect light and be captured to create a digital image. But we don't need to know the details of how that works very much. Mostly we want to know that it is used for converting a digital format, that it's useful because we can immediately view the images on screen, we can edit them and make decisions about framing, take the picture again, and then very quickly upload them onto our computer. And we'll look at some of the places this is used also today. Next are our pointing devices. So these are all ones that relate to the cursor and navigation around the screen on the X and Y and sometimes X, Y, Z axis if we're looking at like the joystick. These include the mouse, which you'll be really familiar with and you've probably all used at school or at home, a trackpad, which you might have on your laptop, which allows you to use your fingers and to access shortcuts, and things like joystick, which are often used in flight simulation or gaming. So next is the keyboard. Now that's the most common input device for data entry. Everybody's used a keyboard. I'm sure you use one most days, and that's normally connected with a USB or you might have a wireless one. And also you could have a keyboard on screen as well. So the keyboard, if you are trained in how to use it, is a really fast input method. So a lot of people are touch type trained. Some people might not be. You probably all have a relative who uses the two index fingers to type and is very, very slow. But for those who are trained, this is a really fast method. Now, there are some risks that are involved with keyboards. So, example, the raised keys on a keyboard you can see here will have gaps in between them. So, what that means is that dirt or debris could become trapped inside. So, they're not great for environments where it might be dirty or there's a lot of mess around. The next issue is repetitive strain injury or carpal tunnel. And this is from repeatedly moving your wrists and fingers for the typing of a keyboard. This repeated movement can cause a repetitive strain, which might be like a arthritis. It makes your hands very hard to use and they can swell up. But a helpful solution to this is to use an ergonomic keyboard. So that would be one that's designed with a certain elevation or might have somewhere for you to rest your wrist so that it's not as much of a large movement each time that you move. So next is the keypad, which we're familiar with from the point of sale and the use with barcodes. And you will have seen these on lots of devices that really only have a smaller amount of space. So when you don't need a full QWERTY keyboard and all of the letters, this is a great advantage when you have a small amount of space. And you might find these in places such as the ATM, washing machines, where there's only a set number of programs that need to be added in, and you perhaps just need up and down buttons to increase the weight of a load. The ATM, the point of sale, where we use it for the banking cards for entering our PIN. Both of those use the same way. Really, any small device like remote control devices, vending machines, and the Internet of Things or any Internet of Things device. And if you're not familiar with the Internet of Things, that's basically look around your room now, look around your house, and any device that is capable of connecting to your home Wi-Fi, that is capable of internet connection, and then allows you to communicate with it probably through your phone. That's an Internet of Things device, and that's one of the biggest uses right now and one of the biggest up and coming technologies. So next we have the concept keyboard. That's another type of keyboard, and it's commonly used in fast food restaurants. And the reason being that it allows you to individually program buttons. So if you have, for example, a fast food restaurant, they sell burgers, they sell fries, they sell combo meals. What you do is you individually program each one of these buttons to represent an individual item. And the actual technology is a flat keyboard. And then what they do is they take a plastic overlay that they label with the items for sale and put it over the top of the flat grid. And that means that it can be customized to individual restaurants and also easily changed if the menu changes. But it has some really, really good advantages in a fast food restaurant. Having these pre-programmed buttons is useful because it means limited training are required. If we think about the keyboard, one of the advantage was that it was fast when you are trained to use it. A concept keyboard doesn't require a lot of training because you just need to select the icons that are available. It also makes it really fast. So instead of typing out the word burger or big whopper or something like that, you can just press the button that it is, and then the options are going to be available for you very, very quickly. So in fast food, that's obviously important because people want their food fast. It also means that you're less likely to make an error. You're not going to make an error typing. You can't really go as wrong just selecting one button wrong. So next is our 2D scanner. Sometimes that's called a flatbed scanner. You might have used one before, and basically it's going to take any hard document, so a hard document being a paper document that you can physically hold, and it will turn that document into an electronic file. Now, what it creates is an image of the text. That doesn't necessarily mean that it is editable text. It's actually creating an image, and then depending on the software that is available, you might be able to edit that image. So for example, if you're using optical character recognition or OCR, then that takes text, so like this 0, this 1, it's able to recognize the shape of the text and then convert that into editable text. This is commonly used software in things like Google Translate, where you might take a photograph of a menu, for example, and have it translated into Japanese. Or if you've ever used an iTunes card, you might have scanned the back of that card to get the number PIN for the money. And it's used in things like PDF editors like Adobe Acrobat, where you can edit text. Then similar to OCR is OMR, which is optical mark recognition. And if you look at this person's test paper over here, you can see them circling answers with dark marks. Those marks will be scanned into the computer, and then they're able to recognize the position, and it can be used for things like grading student assignments or national lottery tickets. Use this sort of system too. We can also use this for passports. So at an airport, a passenger's passport would be scanned, and the data of it, like their nationality, their date of birth, these things will be added into a database for the airport. And also it would scan the photograph of the person for security methods. Now, the biggest disadvantage with a scanner is just that you're never going to get the same quality of image as the original one. But you can get some very good quality scanners, but it's still never going to be as good as the original file. Well, not file, document, because it's a hard document. It's a paper. So how do these scanners work? Well, we need to know the principles of operation. So that's how the actual components inside of this scanner work to take that hard document and represent it into a digital format. So we start by putting a document face down onto the scanner, which has a glass surface at the top, which is shown by this white line here. And what will happen is a moving scan head, shown here, will go up and down the distance of the document. And you can see it represented by this arrow here as well. So that's going to shine light onto the surface of the document while scanning across the whole document from top to bottom. So this light is shone here up to the document. It will then also be reflected back. So light will be reflected back down to some mirrors. So there's a sequence of mirrors. So it reflects off the first mirror here, which is also a moving mirror. So when the scan head is moving, the moving mirror is moving too. And the light bounces off the document back to this mirror and then across to this fixed mirror at the very end. And that will go down to the charged coupled device. So this device is a set of sensors that essentially work as an RGB color spectrum sensor, and they will take the digital data that is reading the reflected light intensity, process that through an analog to digital converter or an ADC, which if you're not familiar with, you do want to learn this term for the exam, and that will then be connected to your USB and plugged into the computer to retrieve the digital file. So you need to remember each of these key steps throughout the process, and that the product of this is a 2D digital image. So now we're familiar with how it works and the principle of operation, let's look at where it's used and why it's useful. So a really common exam question about 2D scanners might be to do with the airport, and there's two main ways that we use it here in the airport. So initially, the passenger's passport will be scanned using a 2D scanner. And what happens is the key data, such as your name, date of birth, nationality, will all be collected from the digital scan, processed through OCR, which is optical character recognition. It's going to recognize each of the key pieces of information, convert them into readable text, and place them into the correct fields inside of the database, which we call populating the database. And these blank spaces here would show some of the fields that we'd be looking for when a passport is scanned. It will also scan the image, which is then used for security. So let's look at the security aspect. Well, that image is taken from the passport, and key positions on the person's face are then marked down. And these key positions will be compared against a photograph of the passenger taken in real time. So the next thing that happens is a digital camera is used to take a photograph of that passenger at security. And you might have had this done yourself when you've gone through the airport and you have the two footprints on the floor, you have to stand on them, you look at the camera, and they take your photograph. Well, what they're doing, they've also got your passport at this stage, so pay attention. They have both of these and they're processing the photographs to compare them for this digital facial recognition. So the facial recognition software is designed to match the key features of the face. So look on the original image, we've got these X's marked, red X's, where the distance between the nose, the shape of the mouth, the length of the jaw, your cheekbones, all of these different measurements are taken and then compared against each other. And it matches these distances, matches these key markers, and then is able to identify if the person stood in front of them is in fact the same person that is on the passport. So the important thing for exam readiness here is to look at the words that are in bold. When you are answering, you really need to make sure that you're talking about facial recognition software and how it compares against each other. The two images that are scanned and one taken by a camera is compared against each other with facial recognition software, and then lists some of these specific aspects and measurements within your answer. So next is the 3D scanner, and that's used for creating a 3D model of the digital image. So the difference with the 2D and the 3D scanner is you're mentioning a 3D model instead of a 2D image. So it's going to take any 3D object, something you can physically hold, and then scan it to a 3D model. Now, this is commonly used in medicine. So, for example, in CT machines or MRI machines, when you want to get a full 3D image of a person's face or bones or a certain area of the body. It's also used in biometrics, so things like a retina and fingerprint scanner, where we're looking at the bumps and grooves in between the finger in order to get biometrics, actually biology. A biometric is the biological scanning of yourself, and that's another identification technique that can be used. It's also used again in airports. So if you're familiar with going through security, you have to take off all your belt and your shoes and things, and then you go through a body scanner. And that's used to get a 3D image of you and identify if there are any unusual objects or something suspicious on your person that they want to pull you aside and ask you more questions. So what are the principles of operation for the 3D scanner? And you're going to find it's quite similar to the 2D scanner, but there's a few keywords that you need to throw in there to make sure that it shows you understand this is a 3D scanner and not a two-dimensional one. So similarly, it's using light. It's going to shine a laser or light over the surface of this 3D object and then identify the X, Y, and Z or Z coordinates that are used for the object. And those measurements will be specifically recorded. And you can see the light being shone here by the projector, and then the X, Y, Z coordinates here shown at the side. And that's the width, height, and depth, which are then recorded as three-dimensional measurements, converted to a digital file, and this will in turn produce a 3D model. All right, so let's have a look at a couple of examination questions. We'll start with one of the easier ones. Very common is to identify the device that is being named. This is just stating the name. It's a one-word answer. So let's look at the first one here, which is this is an input device that works by shining light onto a surface of a document. The light source is automatically moved across the document and the reflected light is captured by mirrors and lenses. Now, before you go ahead and answer, you might want to take the time to look at each question first and use it as a process of elimination, because some of them will have very similar answers and maybe just small differences. Like these first two are very similar devices with just a few keywords that are going to help us to identify. So the second answer says this is an input device where a laser or light source is moved across an object. The width, height, and depth of the object are measured to allow a model to be created. So both of these are talking about light, the shining of light. One is light and one is a laser. Next, it also mentions the surface of a document, whereas the other one is listing a move across an object. And this one mentions the height, depth, and width of an object that is measured to create a new model. Whereas the other one is talking about the reflected light being captured by mirrors and lenses across a document. So when we look at those two, we want to think about the 2D and the 3D scanner. So one of them is using width, height, and depth to create a 3D model, and the other a document. So the first answer is 2D scanner because that deals with the document and not the object. Whereas the second one is the 3D scanner because it's dealing with an object and a model. So now our last device, this is a large input device that is usually fixed to a wall. A user can calibrate the device to make sure that the sensor aligns with a projected image, and the user can either use their finger or a special pen to make selections. So what I would look at here is that it's mentioning specifically it's an input device, and it mentions the use of a projected image. It also mentions the calibration of the device with the sensors. So those key aspects are really big decision makers for us because, as we mentioned, the interactive whiteboard is always used with a projected image and is not a projector itself. So that's our key indicator, along with the use of the special pens and the finger, that this is an interactive whiteboard answer. So our next question is more of a scenario-based question, and you'll notice that it is stating two disadvantages of using a keyboard to input this customer food order. So we're going to be stating, so that's just giving a single word answer with a small sentence to explain it. And we have the Henslow Diner in a local restaurant. The staff currently use a keyboard to input customer food orders into a computer. The food order is then sent to the kitchen. So they want to know two disadvantages of using a keyboard to input the customer food order. So we want to think about the disadvantages of a keyboard, and those are that it can cause repetitive strain injury if it's overused in a certain way, that it is a slow input method if you are not trained, and that the dirt that can gather in between the keyboard, in between the keys, can cause functioning errors if you're using it in a dirty environment. So I think about the fact that this is a fast food restaurant. Pause the video now and have a go at answering these questions yourself first using full written answers. So let's look at my answers here. The first one I went with is that keyboards are a slow input method when the user is not trained. So if you're in a fast food restaurant, we know we want to move quickly. So this is a really good answer for this type of question. Now, I didn't go with the repetitive strain answer specifically because you're probably not going to use that many repetitive actions in the environment, and they do a lot of other things like serving and collecting money and things as well. My second answer, what I went for, is the raised buttons on the keyboard mean that food or dirt from the restaurant could become trapped between the keys. This is a really good one for a fast food restaurant or a food restaurant environment or places where you're using liquid and dirt. So I've gone for something that's really relevant to the scenario and is also a common disadvantage. As is very common in IGCSE questions, we now have a follow through part B answer to this question. So it says a concept keyboard has a flat surface that is overlaid with images of food items available from the restaurant menu. Now, staff can click on an image to add the food item to a customer food order. The Henzo diner wants to change to a concept keyboard to input customer food orders. Explain two benefits of making this change. Now, you might have thought about, even in the last question, that a concept keyboard was really what they should have been using in this environment. And you probably had some good reasons why. Have a go at pausing the video and answering the questions yourself now. Okay, so our first answer is that it's going to have pre-programmed buttons. So with this explain question, we're trying to get 2 marks for every one answer. So the pre-programmed buttons for food items will speed up the order process. So that's our first point. And then we explain why. So we say only one button is needed for a food item to be selected. So it's faster because you only need one button to press. So then the next answer, my first reasoning is that there should be fewer data entry errors. So that's the first point that I'm making and why it's a benefit. And then I'm going to explain why it's a benefit. And that's because each of the food and items only needs one single button press. And also, those are really easily identified by their icon. So they're actually very similar answers. They're both to do with the fact that one button press is going to make this a benefit, and one of them is going to make it faster, and one of them will reduce errors. So what are another two possible answers? Because there's actually 4 that we could use here. So the other one is that the plastic overlay is actually a barrier for dirt. So also the concept keyboard has flat keys. So that stops anything getting stuck between the keys, which is one of the disadvantages of a normal keyboard. Now, my next advantage is that less training is required for the staff to use the concept keyboard because it only has a limited number of input options and they're represented by icons. So again, I'm using an explain technique. I've stated what my benefit is, which is that less training is required by the staff, and then I've explained why. So the next question is asking us to describe the operation of a 2D scanner and a 3D scanner. So this one says describe operation. When they're saying operation, they're looking for the principles of operation, and that is how it works technically. So what are the inner components and inner workings that are happening to make that process happen? And then we're going to need to describe that. So that means full written answers to get 6 marks. So each of these answers is going to need 3 different marks to complete the question fully. And that means that you need 3 different points for each answer. So 3 definite actions that are happening in this operation, described by using full sentences. That's so important. It needs to be full sentence answers. So what are our principles of operation for a 2D scanner? Well, it has a moving a moving scan head that shines light onto the surface of a document. So it scans across the document, shining light onto the surface of that document. This light is then captured using mirrors and lenses, which is reflecting to a CCD, or charge coupled device. Then this capture, or the captured image, is then converted into a digital file. Then this produces a 2D digital image. So each one of those steps, there's 4 of them, would gain you a mark in this question. So if we list all 4 items, then if you forget one of the keywords or you make one mistake, then hopefully you'll still get the 3 marks. But the important things are the scan head and that the light is shone onto the surface. Next is that there's mirrors and lenses capturing that this will become a digital file, and then ultimately that is a 2D image that is produced. So what about a 3D scanner then? Well, that has the same principles with the light. So we're going to mention that there is a laser, and that is shone across the height, width, and length dimensions. You must mention these dimensions, and you can call it XYZ, or you can call it height, width, and length, but you must mention those coordinates and that they are scanning a 3D object. So the light is shone on the XY coordinates of a 3D object. These measurements are then converted into a digital file, and that will then produce, and that's the same as the scanner, in fact, where we're producing a digital file. So both produce a digital file, but this time on a 3D model, it's going to produce a 3D object as opposed to a 2D scanner, which makes a 2D digital image. So if you can memorize these two processes together and just remember those key differences in terminology like object and model versus the document and the image, if you can do that, then this is quite an easy one to remember, and you're just going through the steps, and that's two different input devices you will have your principles of operations for. So look at these keywords, memorize a small paragraph of how it works, and you should be super successful for the exam. So that's all of our different input devices for today. I hope that the examination questions were useful, and if you have any questions or comments, please leave them in the description below. Like and subscribe if you enjoyed this video, and put the notification bell on so you can be the first person to know every time that new content is made. And good luck with your studies.